Hello, this is Howard Becker speaking, and this is the one and only online class. The material might be coming at you faster than what you're accustomed to because normally writing on the board and erasing the board slows me down. But if it's coming too fast, pause the video or replay the video. The third exam has been graded and is on Blackboard. As on the first exam, I added 20 points to everybody's score to get a reasonable letter grade. So the number that's posted on Blackboard is what you actually got, plus 20. 6 of the 7 homeworks that you turned in have been graded. As soon as I grade the 7th, that will be also, the 7 homeworks will be posted on Blackboard. Once the homework is posted, you can figure out for yourself what you need to get a given letter grade. On the syllabus, it tells you how the letter grade is determined. That is, each of the 4 exams is 20 points, homework is 20 points, and then A is 90 and B is 85 and so on. So if you decide you want to get what do you need on the final to get a letter grade of B? Well, that amounts to solving a linear equation, so you don't need my help to do it. There will be an online final exam. I sent you an email with some details. I'll send you another email reminder the day before. I'm going to review the final later in this class, but I want to begin this class by discussing the third exam. Okay, so here's the problem that occurred here's problem 1. You're given the circle with 2 points, 2, 6, and 6, 4. The line intersects the radius. Find the center and the radius. This, by the way, is a problem from homework 14, section 2.8, number 66. Well, the center of the circle is the midpoint. Okay, so the midpoint formula is the average of the x coordinates, 2 plus 6 over 2, plus the average of the y coordinates, 6 plus 4 over 2. And so the center is 4, 5. Now, to find the center, rather to find the radius is the distance from the center to the endpoint. Here's the distance formula. The difference in the x's squared plus the difference in the y squared, square root. So if you take the center, which you now know, 4, 5, and one of the points, say 6, 4, you plug into the distance formula and you get that the square root of 5 is the distance. You could also take the other point, instead of 6, 4, 2, 6, and look at the distance between it and the center. An alternative way to do it is that the radius is half the distance between these 2 points. So you could take half the distance between these 2 points, plug into the distance formula. You get a half square root of 20. That's a half times the square root of 4 times the square root of 5. Square root of 4 is 2. So again, you get square root of 5. You did not have to simplify. This was an acceptable answer. So we get the center, 4, 5, radius, square root of 5, 5 points for each half of the problem, 10 points total. Okay, now here's problem 2 on the exam. Find the center of the radius of the circle with this equation. This problem is from homework 14, 2.8, number 53, 54, 61. All 3 of those problems are just like this. Okay, well, here's the standard form for a circle. HK is the center, R is the radius. So we take this equation and we put it into standard form by completing the square. Now, I did both parts at the same time. You can do them separately. So let's just take the x part. You add a number, subtract a number. What you add is 8 over 2 squared. 8 over 2 is 4 squared is 16. Then this becomes a perfect square, x plus 4 squared. You do the same with y. Y squared minus 2y plus 1 minus 1, add 1, subtract 1. This is a perfect square, y minus 1 squared. So you get x plus 4 squared plus y minus 1 squared is negative 16 minus 1 plus 13. And that's x plus 4 squared plus y minus 1 squared is 4. And now you can just read off from the standard form. H is negative 4, k is 1, so that's the center. And the radius squared is 4, which means the radius is 2. If you said the radius is 4 rather than 2, you got 3 points out of 5. Now, problem 3. Problem 3 is homework 19, section 4.3, exercise 54. Write the following expression as a single logarithm with coefficient 1, that is condense. Well, you first use the power rule. 6 times log x is x to the 6th. Same here. Log of y squared is 2 log y. And then you use the fact that the log of the product is the sum of logs. Using that backwards, we get the answer as the log to the base b of x to the 6th y squared. Problem 4 is literally a homework problem. This is problem homework 15, section 3.1, exercise 55. You'll have 600 feet of fencing to enclose 3 sides of a rectangular plot. Find the dimensions that will maximize the enclosed area. So this is a word problem. We have to turn it into a math problem. Now, the only kind of math problem we had where you maximize anything is where you have the vertex of a parabola. So we got to turn this into some form of quadratic function and find the vertex. Now, if you take calculus, you'll be maximizing a lot of things, but here, the only thing you maximize is a quadratic, and it's the vertex of a parabola. Okay, so I'm going to call this side x and the other side y. X is the length perpendicular to the river, y the length parallel to the river. You could have done it the other way around. We know that x plus y is 600, so you want to solve for one variable in terms of the other. I solve for y, you could solve for x. 600 minus 2x. Now here's the standard form for a quadratic, or for the equation of a parabola. A times x minus h quantity squared plus k. The vertex occurs at hk. So the maximum, well, this opens down, so the maximum occurs when x is h, and that maximum value will be k. Well, we want to maximize the area, which is x times y, but there's 2 variables, so we get rid of 1. X times y is 600 minus 2x. So do the algebra, minus 2x squared plus 600x. Again, we use completing the square to put it in standard form. Okay, so 300 over 2 is 150. We add 150 squared, subtract 150 squared, and we get the area is -2 times the quantity x minus 150 squared plus whatever this number is. Okay, and this is standard form. A is negative, so it opens down. The maximum area is this number, but that's not asked in the problem. The maximum occurs at x equals 50. So when x equals, 150. When x is 150, we get the vertex. The area is 2 150 squared. If x is 150, y is 600 minus 2 times 150, or 300. So the length parallel to the river is 300. The length perpendicular to the river is 150 feet. If you didn't give units, you lost a point. It's 9. Because the answer is 300 feet, not 300 inches or 300 miles or anything like that, and not 300. Okay, let's go to problem 5. Problem 5 is it's homework 16 and 3.3 exercises 1 and 12 are both division. So you just divide, and you can use synthetic division if you want. I didn't. But x times x plus 6, that's x squared plus 6x. You subtract, you get 2x plus 15. Put a 2 here. 2 times x plus 6 is 2x plus 12. 15 minus 12 is 3. So the quotient is x plus 2. The remainder is 3, which is indeed of lower degree than the divisor. And so that's the answer. Now, problem 6, which I thought was a gift. No, I'm sorry, not 6. It's the next one, a later one, which is a gift. Problem 6, this is homework 20, 4.4, problem 20. Solve this equation. Now, there's 2 ways to do it. One way is you can write that 8 is 2 cubed, so it's 2 cubed to the power 1 minus x is 2x plus 2. Now we use the power rule, or the law of exponents. This is 2 times the power is 3 1 minus x, x plus 2. That means the exponents are the same, or if you want to get more formal, you take log 2 of both sides and they cancel. 3 times 1 minus x is x plus 2. That's a linear equation. X is a quarter. The answer is a quarter. An alternative approach would be to take the log of both sides, log 2 of both sides. Now we use the power rule for logarithms. This 8 to a power is the power times log 2. Sorry, log 2 of 8 to a power is the power log 2 of 8. Here they cancel. Log 2 of 8 is 3. So you get back the same equation. 3 times 1 minus x is x plus 2. Answer is a quarter. You did not have to know that log 2 8 is 3 to get this right. You did not have to simplify. So if you just left this as log 2 8, you would have got full credit, assuming everything else is right. Now the whole problem is 10 points. It's 5 points for taking the log of both sides to the same base, and 2 points if you took the log to 2 different bases, which is wrong. You got to use the same base. Page 6. Problem 7, find all complex solutions to this equation. Well, we had a lot of problems like that. Homework 16, section 3.4, 9, 12, and 20 are all problems like this. Now, this is a degree 3 polynomial, and the way you solve a degree 3 polynomial, if you can solve it, is try to find one root. If you can find one zero, then you can find the other 2. as I'll explain in a moment. Now, one way to find zeros, if now all else fails, is the rational zero theorem. So if there is a rational zero, its denominator divides 1, so it's 1, and its numerator divides 13, 1 and 13. So the rational zero theorem says if there is a rational zero, it's one of these four numbers, plus or minus 1, plus or minus 13. If you try them, you'll see that 1 is a solution. Nothing else is a solution. Okay, so you got 3 points if you got this far, and 5 points when you got this far, that 1 is a solution. And that means that x minus 1 divides your original polynomial. That's 6 points. And then 4 for the rest. Well, what do? You divide. You divide x cubed minus 5x squared plus 17x minus 13 by x minus 1. We've done this before. You get the quotient, and the remainder is 0. So the original polynomial is x minus 1 times x squared minus 4x plus 13. The zeros of this are the zeros of this, which is 1, and the zeros of this. You solve this by the quadratic formula. X is negative b for plus or minus square root of b squared minus 4ac over 2a, which is 4 plus or minus the square root of negative 36 over 2. 6i squared is negative 36. So that's 4 plus or minus 6i over 2, or 2 plus or minus 3i. So we got 3 solutions, 1, 2 plus 3i, and 2 minus 3i. And again, you should note that complex numbers always come in pairs, a number and its conjugate. Okay, problem 8, the one that I thought really was a gift. This is homework 17, 4.1, 67, and 68. You're given a formula. S is C times 1 plus R to the T, models inflation. C is the value today. R is the annual inflation rate. S is the inflated value. T years from now, what is the inflation? The inflation rate is 2%, which is 0.02 per year. How much will the house whose C value is 385,000 be worth in 10 years? And it says you don't have to simplify. So you just plug in. C is 380. You plug into the formula. Can I fit this all in here? Just barely. C is 385,000. 1 plus R is 0.02. T is 10. So this is the amount. That's roughly $469,313. I accepted either of these answers. Problem 9. This is homework 18, 4.2, number 78. Find the domain. Well, the domain of the logarithm function is the positive numbers. There's no such thing as log of 0 or log of a negative number. So that means x minus 8 is positive, or it means x has to be greater than 8. You could write this in the interval notation. That's open interval though. 8 is not in there. The interval greater than 8, less than infinity. And lastly, solve the equation. Well, the way you solve a logarithmic equation is you take logs, but first, or at least sometime, you have to condense them. So the log of the product is the product of the logs. So this is the log of x plus 6 times x plus 4. Now, when we got I'm sorry, when we got a variable inside a logarithm, we exponentiate both sides. So we take 2 to both sides. If a is equal to b, 2 to the a is equal to 2 to the b. 2 and log cancel. So we get x plus 6 times x plus 4 is equal to 8, 2 cubed. Okay, so you got 3 points if you got to here and 6 points if you got to here. Now, when you get to here, for the remaining 4 points, this is quadratic. Yeah, this is quadratic. X squared plus 10x plus 16 is 0. You could use the quadratic formula, or you could factor, and you get x is minus 8 or x is minus 2. That means this quadratic equation has 2 solutions, negative 8 and negative 2, but you've got to check the domain here. Negative 8 is not in the domain. If you stick a negative 8 in for x, you're taking the log of a negative number. That's like dividing by 0. It's meaningless. So negative 8 is no good. 2 is good. Negative 2 is good. You plug a negative 2 in for x, you're taking the log of positive numbers. So this has one and only one solution, namely negative 2. If you got this as 2 solutions, that was worth 8 points, and 2 points for recognizing that this one is no good. Okay, so that concludes my discussion of the test, the third test. Now, in the remaining of the part of the class, I want to discuss the final. The final exam covers the whole course. It basically has 3 parts. All 3 parts are covered about equally. There's going to be 10 problems. Again, as in the midterm exams, there will be assigned homework problems with the numbers changed. So you had a total of 200 homework problems. 10 of those 200 will show up on the exam. The difference is, because it's online, it has to be multiple choice. It will be. And because it's online, there's no way to proctor it. So might as well make it official. It's open book. So your grade should be higher for those 2 reasons. It's multiple choice and open book. But the grades will be lower because I can't give partial credit. Each of the 10 points is problems is either true or false, is either correct or incorrect, 0 or 10. Now, there's a lot of stuff in the textbook about calculators. Ignore that. But except for that, we covered everything in chapters and sections 1 to 16, 2.1 to 2.8, 3.1, 3.3, 4.1 to 4.4. You know, in 3.2, there's mostly we didn't cover it. We covered the definitions of polynomial and of degree and the leading coefficient test. And we covered the rational zero theorem, but that's about it. And in and the leading coefficient test. In 3.4, we covered the rational zero theorem and its use in finding zeros of a polynomial. That's like the problem I worked a moment ago on the third exam. You look for rational zeros, and if you find one, then you divide and you find the other 2. We didn't cover anything else from 3.2 to 3.4. That is to say, we did not cover, Descartes' rule of signs and all that other stuff. All of the homework problems, and therefore all of the test problems, are from the book and from this part of the book. So let's see. To a large extent, though not totally, this is a class in solving equations. Okay, well, there's linear equations. I hope you can do that. Then there's rational equations with a variable in the denominator. And when that happens, you've got to worry about the domain. In this particular rational equation, which is very easy, they're generally harder than that, you can see that 2 is not in the domain. You're dividing by 0. So you got to check the domain. Now, when it's rational, you multiply through by the denominator. So I multiply both sides by x minus 2. I get 1 is 4x minus 2. That's linear. You solve. X is 9/4. Check your answer. Make sure it's in the domain. Well, that's no problem here. So that's the answer. Rational equations are generally more complicated than this one, but this is the procedure. You multiply through by the denominator, and then you worry about the domain. Then there's quadratic. Well, if all else fails, you can use the quadratic formula. And and then there's what's known as quadratic in form, where you make a substitution and it's quadratic. So here we take u to be x squared, which means x is plus or minus the square root of u. Now x to the fourth, that's x squared squared or u squared. U squared plus 6u plus 8 is 0. That's quadratic. You can solve by factoring or quadratic formula. U is -4 or u is -2. Now we plug back in. That's what u is, but we want to know what x is. Well, x is plus or minus the square root of u. So there's 4 solutions. X is plus or minus the square root of -4, which is plus or minus 2i. And x is plus or minus square root of -2, plus or minus square root of 2i. And you can't get any simpler than that. Then we have radical equations. That means you have equations where you got a variable inside a radical. Now again, you have to worry a little bit about the domain. Here the domain is everything greater than or equal to -1. You can't take a square root of a negative number. And the way to solve is to take it to a power. So we'll square both sides. X plus 1 is 25, x is 24. We check the domain. Yeah, that's okay. When x is 24, we're not taking the square root of a negative number. Now, radical equations may be more complicated than this, but the method is this one. If you got a square root, you square both sides, and you always have to check the domain. And finally, we have polynomial, well, not finally, but we come to polynomials with degree greater than or equal to 3. Now, one way would be factoring. If, for example, this equation, you can easily factor out an x, and then x is 0, or x squared plus x plus 5, is 0. And so that's quadratic in form. And okay, now sometimes if you don't see instantly how to factor, you use the rational root test. There was a problem like that on the third exam. If you use the rational root test, you can find the root, and then you divide, and it's a linear times a quadratic, if you're lucky. Now, then there's equations with variables in the exponents. That's recent material, I don't have to review. You take the log of both sides, and equations with variables inside a logarithm, you exponentiate both sides. Okay, so solving equations is an important part of the course. Another part of the course was word problems. Now there's only 2 kinds of word problems that have come up in this class. One translates into solve the equation. So, you label the variables and try to get an equation. You may have to solve for one variable in terms of the other, but eventually you get an equation in one variable and you solve it. And then you go back and answer the question in English. So one kind of word problem is solve the equation. The other kind of word problem translates into find the vertex of the parabola. That was the kind that occurred on the third exam with the three fences. Now, another important point in this class, you should be able to go back and forth between geometric and algebraic information. So let's start with lines. Given a point and slope, or given 2 points, you should be able to find the equation of a line. And given an equation of line, you find slope and intercept. So there's two important canonical forms. The standard form, where you're given a point x1, y1, slope m, point slope form, y minus y1 is m, x minus x1. Slope intercept, y equals mx plus b, m equals slope, b is the y-intercept. So given geometric information, find an equation. Given an equation, find geometric information. That's not only true for lines, but also for circles. So given a center and radius, you should be able to find an equation of the circle. And given an equation of the circle, find the center and radius. So there's the standard form where the center is hk, the radius is r. If the equation is not in standard form, you use completing the square. You complete the square to put it in standard form, just like the problem that occurred on the third exam. And then there's parabolas. Given an equation, you should be able to put it in standard form and find the vertex. Or in a minimum maximum problem, find the maximum, the minimum or maximum. Well, here's the standard form. Y is a times the quantity x minus h squared plus k. The vertex is hk. If a is positive, it opens up, so there's a minimum. A is negative, it opens down. There's a maximum. We also discussed transformations and graphs. Now, I'm not going to ask you to draw a graph. It's multiple choice, so that's obvious. But even if it was, it's not. You're not going to have 5 graphs and ask which one works. But you should be able to understand transformations in graphs: horizontal and vertical shift, horizontal and vertical stretch, reflection about a line, and symmetries. Now, you have to do algebraic simplification. You need to do that to solve equations. But you also need that, or to put an equation in standard form. Say you want the equation of a parabola in standard form. You have to do a little algebra. You also need this to put complex numbers in standard form. So we got another standard form, which you should know. A complex number has the form a real number plus another real number times I, where I is the square root of -1. Every complex number can be put in standard form. Now, if it's adding 2 numbers, that's fairly straightforward. So for multiplication, what about division? Well, to put a quotient in standard form, you multiply by 1 in the form of something over itself, and that something is the complex conjugate. So let's say you're given this complex number, 1 plus 2i over 3 plus 4i, and asked to put it into standard form. Well, you multiply through by the complex conjugate, the denominator by the complex conjugate. I should have said complex conjugate of the denominator. So that's 3 minus 4i. multiply by 1 in the form 3 minus 4i over 3 minus 4i. On the top, you get this 3 minus 4i plus 6i minus 8i squared. On the bottom, 9 minus 12i plus 12i minus 16i squared. On the top, remember this is 8. Negative I squared is negative 1, so that's 8. 3 plus 8 minus 4i plus 6i. On the bottom, these cancel, and therefore you get 9 plus 16. Or another way to look at it is this is a square plus a square and a square minus a square. So you get a square, 3 squared minus 4i squared, that's plus 16. Either way is fine, but the point is you've now got rid of the i's in the denominator. So it's 25 in the denominator, no i's. You got 11 25ths plus 2 25ths times I, and this is the standard form of a complex number. Another topic, another topic that we spent a fair amount of time on was composition and therefore inverse functions. So you should understand the concept of an abstract function and be able to think about the function, even if we don't know what it is. We don't have a formula. But given two functions, you should be able to find the composition in either order. That's pretty easy. There's an outside function and an inside function. And you should be able to, if it's 1-to-1, find the inverse. Now the rule for that is easy. Only doing it may not be easy. So if y is f of x, to find f inverse, you want to solve for x. X is some formula of y. So let's take this. F of x is x minus 6, x plus 5. You want to find the inverse. Well, okay, set y equal to x minus 6 over x plus 5, and you solve for x, multiply through by the denominator. And now we get a linear equation in the variable y. Treat x as a number. xy plus 5y is a linear equation in the variable x. Treat y as a number. We want to solve for x. xy plus 5y is x minus 6. A linear equation in x. xy minus x is 6 minus 5y. xy minus I, 6 minus 5y. X is 6 minus 5y over y minus 1. And this is f inverse of y. Okay, if you prefer, you can now change the variable here to x and get f inverse of x. But f inverse of y is fine. And you can check your answer. You can compose your original function with this function. And if they're inverses, you should get the identity function. If not, not. Okay, now, as I mentioned earlier, you need to be able to simplify algebraic expressions. And toward the end of the course, the very end of the course, we had laws of exponents and laws of logarithms. This is so recent, I don't feel the need to review, but it's things like the log of the product is the sum of the logs and so on. Those laws of exponents and laws of logarithms are necessary or may be necessary on the test. You may have to do what the author of the book calls condense or expand. Okay, well, that's a very short review of the entire class. If you have any questions between now and the exam, email me the question. I will try to answer them. If you want me to work an exercise in the book, again, email, I'll work it. I may have to send you, scan it and send you a PDF file, but I will answer your questions.